Okay, good afternoon, Spartan fans. I am starting lesson 10 with you all today. So we're going to represent, name, and evaluate functions today. So we do functions in a few different ways, but the thing I want you to remember is all the things about a function that Mr. Kaz talked about in the last lesson are still true. And we'll go over exactly what that means in a minute. But let's go over ways that we can represent a function. Now, the first way we can represent a function is by a table. So let's do some review real quick and see if this is indeed a function, okay? When I have 0 in for my input, I get a value of 1. 0 produces 1. And when I have 1 as my input, it produces a value of 2. When I have 2 as my input, it produces a value of 4. When I have 3 as my input, it produces a value of 8. When I have 4 as my input, it produces a value of 16. When I have 5 as my input, it produces a value of 32. Now notice that my inputs, in other words, my domain, there's nothing repeating in my domain. Okay? So this is indeed a function. Okay? Another way to represent a function is by what we call set notation, meaning that I define f right here as something that goes from a first set, which I call the domain. So remember, this was a domain, and this is also a domain. And then it assigns it, let me erase this side here so you can see the arrow right there. It assigns it to another set, which I call the range, which is also what this guy was. That's my outputs. And this is also my range. Now, notice that my 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. So you notice that the domain is exactly the same. Now let's look at my output, also called the range. 1, 2, 4, 8, 16, 32. 1, 2, 4, 8, 16, 32. So my ranges are exactly the same as well. And then there's another little bit, and sometimes you'll see this and sometimes you won't. You'll see the such that x goes to 2 to the x power. Sometimes you'll see this, sometimes you won't. Sometimes you'll get a rule that defines how to set the domain to the range. Okay? That's a second way to express a function. A third way to express a function is through explicit function notation. Explicit function notation right there. And this looks a lot like equations that we've been doing before. And this is f of x equals 2 to the x power. Notice that this right here looks a lot like this right here. Okay? It looks a lot like this right here. And indeed, it is the same thing. Because if you notice, when I put 0 in for x, when 0 is my input, I get 2 to the 0 power, which equals 1. When 1 is my input, I get 2 to the first power, which equals 2. So 0 and 1, 1 to 2. When 2 is my input, I get 2 to the second power, which equals 4, which matches that. And I could go all the way through and get this, this, and this. So now I've shown you 3 ways to do the same thing, to show the same relationship. A 4th way is what we call sequence notation, or another thing we call recursive. Recursive. And what this means is I get a starting point right here. Put my starting point last, but that's my starting point. So when my little number equals 0, I get 1. Just like here, when I had 0 as my input, I got 1 as my output. Now, the interesting thing about recursive notation is I know how to get the next one. So if I have 0, I put 0 in for n here, and then this gives me the first one. So I got, it's hard for me to describe, so I'm just going to write it down. So I got a to the 0 plus 1 is going to equal 2 times a to the 0, or a sub 0. Okay, well, a sub 0 equaled 1, so I'm going to put that in for there. So then a, and I'm looking at this part right now, I'm looking at this one right here, that is going to be a sub 1. And that's going to equal, again, I'm taking this term right here, and I'm assigning it into there. So now I get 2 times 1, which equals 2. So a sub 1 equals 2. Now I can do, oops, 2 times 1 equals 2. Sorry about that, kids. Now I'm going to say a to the 1 plus 1 equals 2 times a1. Well, a of 1 plus 1, that's a of 2, and that equals 2 times a sub 1. Well, a sub 1 equals 2 right here, right? So I can substitute that in, equals 2 times 2, which equals 4. And I get this one right here. So these are 4 different ways to showing you one relationship. So it's important to note that these all are let me rewrite that. That these all represent the same function. And I got an exclamation point right there just to show you how important that is. So let's go to the next page. We're going to see explicit function notation most frequently. So that's what we're going to look at. And this is how I am showing my explicit function notation. Okay? Now, the x in f of x, this part right here, that guy that I'm highlighting right there, that is called the input, and the input is part of what we call the domain. So now, very important that you look at this, because this is going to be important. The domain is the set of all allowed inputs. Now, this right here is my domain. So that's telling you what numbers you can put in for x. Now, if the domain is not defined, so now I'm back down here. If the domain is not defined, meaning I don't have this stuff right here, this stuff is gone, then you can assume for now that the domain is all numbers. So any number that you can think of, I can put in that function. Now, the whole of f of x. So now I'm right here. I'm looking at this whole thing. It's called the output, and it is part of the range. And the range is defined as the set of all outputs. Sometimes when the range is not given, you have to compute the range to find it. All right? Now I want to go to the last part of this lesson. We'll come back to these guys on a future date. But right now, I want to show you how to work explicit function notation. So I'm defining f of x as 3x plus 4. And I want to find f of 0. I want to find this guy right here. So f of 0, you notice how 0 is in the same place as this x is. You see how them two things are in the same place. So what that means is I'm going to replace everywhere I see an x in the equation with a 0. So this is going to equal 3, see the x right here? I'm going to put that in, I'm going to replace that with a 0, and then plus 4. And now I'm just doing math that I already know how to do. I do my multiplication first, so this equals, well, 3 times 0 is 0, plus 4. And then 0 plus 4 is 4. So f of 0 equals 4. F of 2, you do the same thing. I replace I replace my x in the equation right here with a negative, or with a 2. So it's 3 times 2 plus 4. Now I do multiplication first again. 3 times 2 is 6, and I add 4, which equals 10. So f of 2 equals 10. Now I want to see if you guys can do the third one on your own. I want to see if you can do f of negative 2. So do that in your notes and have that ready tomorrow. Have a good day, kids.